The rocket lifts off, and for a few seconds, everything looks perfect. Then it doesn't. A rocket launch failure can scatter debris across a radius of several miles within seconds. That's not a worst-case guess. That's the exact reason exclusion zones exist in the first place. Most people assume rocket launches are dangerous mainly for the people on board. They're not the only ones at risk. Aerospace safety engineers calculate exclusion zones using some of the strictest math in the entire industry. Dr. Michael Bloomfield, a former astronaut and safety engineer who has worked on launch risk assessment, helped explain how these zones actually get built. His work focused on something most spectators never think about. A launch failure doesn't scatter debris randomly. Engineers model thousands of possible failure scenarios, tracking where fragments could land based on speed, altitude, and wind. Which means the safety perimeter isn't a guess, it's the outer edge of a massive statistical simulation. So why do exclusion zones look so much larger than the rocket itself? Because debris doesn't fall straight down. A rocket breaking apart at high altitude can send fragments outward at speeds far exceeding a falling object's terminal velocity. Some pieces can travel for miles before ever reaching the ground. Which means the danger zone isn't shaped like the rocket, it's shaped like every possible way the rocket could fail. Here's the part almost nobody expects. Most debris fields aren't caused by explosions in the traditional sense. They're caused by structural breakup, as an out-of-control rocket experiences aerodynamic forces far beyond what it was built to survive. Which means the failure often looks less like a fireball and more like a vehicle tearing itself apart from the outside in. Now, think about where the real danger actually is. Launch sites are deliberately placed near coastlines or unpopulated areas specifically to minimize this risk. Range safety officers monitor every launch in real time, with the authority to destroy a rocket mid-flight if it veers off course. Which means the fastest possible response to a failing rocket isn't waiting to see what happens, it's ending the flight immediately. Here's where the story turns stranger. This destruct decision has to happen in seconds, based on incomplete data, weighing the debris risk of destroying the rocket against letting it continue. Officers train extensively for this exact split-second call. Which means for a range safety officer, survival for everyone on the ground can come down to trusting live data over instinct. So what actually happens to someone caught within a debris field? Fragments from launch failures can range from tiny pieces to large structural sections. Emergency protocols for coastal communities near launch sites typically include sheltering indoors and away from windows during active launch windows. Which means for nearby residents, survival often isn't about running, it's about being indoors before the countdown even begins. Here's the part investigators find particularly telling. Historical launch failures have driven continuous refinement of exclusion zone calculations over decades. Each incident adds real data to models that were previously built on simulation alone. Which means today's safety margins exist specifically because of failures that came before them. So could you actually survive debris from a rocket launch failure? For nearly everyone near a launch site, survival was never really in question because the exclusion zone was built to make sure of it. A countdown, a brief flight, a silent, calculated boundary drawn miles before anyone ever needed it. That boundary isn't paranoia. It's decades of failure data, converted into a distance nobody standing inside is meant to cross.
Rockets have failed since the earliest days of spaceflight, long before safety math caught up to ambition. And maybe that's the real reframe. We watch a launch and see triumph, a controlled explosion aimed at the sky. But surrounding every launch pad is an invisible line, drawn by people who spent decades imagining every way it could go wrong. The real achievement was never just reaching orbit, it was making sure everyone standing outside the fence gets to watch it happen safely.